Greetings, comrades. I'm going to start this at a cellular level because here we've got an individual cell. Your body is comprised of trillions of cells that all have a specific function. And these cells need oxygen in order to thrive and do their thing. So therefore we need a mechanism where we can have a gas exchange when the oxygen's being used up, because the cells become carbon dioxide rich and oxygen poor. So therefore we have the exchange occurring when the cell unloads its carbon dioxide onto a red blood cell, and in exchange it will top up that cell with oxygen so that cell can do its thing. So let's look at this in a broader context, because all those cells in the body, they've unloaded their carbon dioxide, and so now those blood cells are oxygen poor. So we're focusing on the left side of this diagram. So therefore that oxygen poor blood will be transported via the capillaries and the veins back into the heart and the lungs, so we can reoxygenate it, ready to circulate once again back to those cells. Now, it's worth pointing out that when you look at some of the images that you'll see in class of the heart and lungs, it kind of appears as though the lungs are on top of the heart. And that's just basically to help you understand the role of the chambers of the heart, of the lungs. But in reality, the lungs actually surround the heart for a very strategic reason. So just keep that in mind when you're looking at images of the heart and lungs. All right, now, let's get down to a bit of an audit of the key features of the heart that we need to know. Alrighty, so as a bit of an audit, what you can do is access a picture of the heart that's got the four chambers, the valves and the vessels, and then have a go at labeling it, because if you can do that, that's a low level of understanding. But if you can explain their function, that's a high level, and that's where we're going to go with the video. So let's start by looking at the entry of the blood into the heart. So the vena cava is the vein in which that oxygen poor blood has come from all the cells and will enter the heart via the right atrium. That's the chamber where the oxygen poor blood will enter. Now, as the blood is filling the right atrium, it will create pressure. And that pressure will cause the tricuspid valve to open up. So that's right here. And the tricuspid valve will enable the blood to flow into the right ventricle. So ventricles are down at the bottom of the heart. The atrium is at the top. Now, the good thing about the valves is they're one way. So once the atrium empties, then it will the valve will close up to prevent backflow. Now, same mechanism with our right ventricle. As the right ventricle fills, it will create pressure on the valve, and this time it's the pulmonary valve, which is right here. And so the pulmonary valve will open, and that oxygen poor blood will now exit the heart. It'll come out via the pulmonary artery, so that's just over here. And then let's just zoom out for a tick. That oxygen poor blood will now, let's do it in blue here, will now circulate to the lungs, where it will go through a gas exchange at the little air sacs in the lungs, the alveoli, with the capillaries. And now that blood is reoxygenated, so it is ready to enter the heart, re-enter the heart through for a second trip. So let's just zoom in. And this time, it's getting a bit ugly here, apologies. This time the blood is going to enter into the heart via the pulmonary vein. And it's going to do so in which chamber? in the left. Whoops, that's a bit ugly. Okay, let's just draw an arrow to improvise. So we've got the left atrium here is our upper chamber. And again, that's going to fill up. Let's just zoom out a bit. That's going to zoom out. That's going to fill up. And this time the mitral valve is going to open up to enable that oxygen-rich blood to basically enter into the left ventricle. We're nearly done here. Now, as the left ventricle fills, again, that creates pressure on the aortic valve, which is very hard to see on this diagram. So it's actually right here. And what will happen is I'm going to draw this in blue, or let's make it orange. And that blood is going to exit the aorta. It's oxygen rich, and it's going to basically reach all of the cells so we can repeat that process.